Welcome to the GatesAir instructional video that discusses RTAC setup for GatesAir Television Transmitters. To complete this procedure, the following equipment is required: a power meter with an SMA female adapter, a laptop, and a spectrum analyzer are optional equipment. First, let's take a brief moment to discuss what RTAC is. RTAC is an acronym for Real-Time Adaptive Correction. The primary purpose of RTAC is to compensate for nonlinear distortions within the amplifiers and RF components of the transmitter. RTAC also compensates for linear distortions caused by RF components such as channel combiners. This introduces group delay into the system. In this example, the blue trace indicates an uncorrected digital carrier, while the yellow has been corrected by RTAC. Notice a substantial difference in noise. In order for RTAC to function correctly, two samples are required: a pre-filter sample that is before the low-pass filter, and a post-filter sample, which would be after the station combiner and bandpass filter. These are labeled in the drawing above as RTAC pre-filter sample and RTAC post-filter sample. These two RF samples will terminate on the exciter or LPU on the SMA bulkheads labeled filter post and filter pre. RTAC sample levels are required to be between plus 5 dBm and minus 20 dBm. Ideally, they should be between 0 and minus 10. Once aligned, the pre- and post-filter samples should be within 1 dB of each other. Finally, our samples need to be measured at the input to the exciter to compensate for any line loss within the RF cabling. To start the procedure, we are going to remove the pre-filter sample from the back of our M2X exciter and attach it to a power meter. As you can see, our sample level is minus 0.2 dBm, which is right on the edge of what is considered to be ideal. So just to put us more centered in that ideal range, what we're going to do is attach a 5 dB pad in series with that RF sample cable and remeasure. So now we're hooking it back up. And as expected, now our sample level is at minus 5.35 dBm, which is ideal. So now that we have this sample level centered up within the ideal range, we are going to reattach this sample level with the pad in line to the back of the exciter. Next, we need to move on to the post-filter sample. And remember that this sample needs to be plus or minus 1 dBm from the pre-filter sample. So we're going to remove it and hook it up to our power meter. As you can see, our sample level is really close to what our first one was, around 0 dBm. We need to be within plus or minus 1 dBm of the minus 5 we set up the pre-filter sample for. So we're just going to get another 5 dB attenuator, and we're going to hook it up in series with the sample line and the power meter again, and remeasure it with the power meter. So we're just screwing in that RF attenuator now and hooking it up to the power meter. And as expected, we have a minus 5 dBm reading, which is perfect for what we're looking for. So now we can just remove the SMA pad and the cable and hook it back up to our exciter. And we've finished our alignment procedure. Both of our samples are within 1 dBm of minus 5, which is right in the ideal range for the M2X exciter. This concludes our instructional video. If you have any questions, give us a call at 217-222-8200 or visit our website at www.gatesair.com.